Good afternoon, everyone, and welcome to IFMA Conestoga's focus session on sustainability. First off, I'd like to thank Honeywell, our sponsor for today, for funding the event. I'd also like to thank the IFMA Conestoga Board of Directors. They were instrumental in organizing this event, setting it up, and getting all the speakers to show up. First off, my name is Rick Krause. I'll be the host MC for the session this afternoon. And obviously today we're going to be talking about sustainability. Now, sustainability to me is truly the buzzword of the 21st century. We hear about it in the news, online, and even between friends or colleagues. And it's one of those words that it really means something different to each person. So that's exactly what the three speakers are going to do here today. They each have their own spin on what sustainability not only means to them as a person, but also to them as a professional and how it can apply to the workplace. So we have a variety of different professionals, and each speaker will talk for about 30 minutes, have a presentation, and afterwards we'll do a 15-minute Q&A session where you'll be welcome to ask your questions and get answers. And then afterwards we'll have a 5-minute break between each speaker just to walk around and for us to switch around the microphones and things. So we do have a tight schedule. I know people do have to get back to their real live jobs. We'll also put up some contact information if anyone needs to speak with him afterwards. So without further ado, I'd like to introduce our first speaker with an undergraduate degree in both physics and engineering, as well as a Master of Applied Sciences in Mechanical Engineering. Steve Kemp has been an advocate for energy efficient design right out of university. While also volunteering as a chairperson for the Energy and Engineering Technical Advisory Group for the Canadian Green Building Council. Steve is currently the president of the Canadian chapter of the International Building Performance Simulation Association. Right now, he's working as a partner and the division head of the Energy Performance Group at Enermodal Engineering, which I'm sure you've all heard about, who has certified over 80 LEED buildings and is currently working on over 280 LEED projects. So please give a big hand for Steve Kemp.
What is the importance of sustainability, which is a slightly different topic for me. I work in sustainability all the time. My primary focus, and you'll get that flavor from the presentation, is primarily energy use, and in particular energy use in buildings, which I think is a big part of sustainability. It's a much broader topic than just that, but that is the particular slant I'm going to bring to it. Worthwhile that, in fact, someone actually came up with a very good definition of what sustainability is. And so I already mentioned that there's a lot of different, means a lot of different things to a lot of different people. But back in 1972, the UN had a conference on the human environment, and they eventually struck up what was called the Brundtland Commission. And the Brundtland Commission basically created a report that was had the widely accepted definition exactly what is sustainable development. And it's here. Sustainable development is development which satisfies the current needs of society without compromising the needs of future generations. This is actually slightly paraphrased from what was actually in the report. But if you want to put it in financial terms, it's living off your interest and not off your capital. If you keep going into your bank account, and if you're living off your interest rate, and you keep dipping into the capital, you're eventually going to run out of money and you're not going to live. You can kind of think of the resources of the planet that way. Here's another one, and this was done by accident. General Motors put up a website, and they said, come to our website, pick your favorite car, and create an ad campaign for it. And they opened it up to everyone on the internet, and this was one of the most popular ones. So when you open up to the wilds of people out there, amazing things can happen. Not quite the message they wanted to put out there, but it was one of the most popular campaigns that came out of it. Does anyone here understand or know the story of Easter Island? A little bit? So back in the 1600s, I think it was the 1600s, when the Europeans first found Easter Island, they were amazed at all these statues that were there. And they weren't so much amazed, I mean, would aliens do it and all that. The reason they were amazed is, one, it was a very small population of people. And the island was absolutely bare. There was no trees. They couldn't figure out how you could move such huge lumps of stone without any tackle, without any lumber. Like, it just seemed like it couldn't be possible. And these people were the people that were living there were primarily dependent on fishing to sustain themselves. And their boats were all made of the driftwood. So modern archaeology has come to the island and figured out what actually happened. And what actually happened was the island wasn't always without a forest. The people that came and that populated, and they were coming over from Polynesia and moving across the ocean, they brought with them some domesticated animals, they brought with them some crops and sweet potato. And they set up a society that was, again, largely based on fishing, and they utilized the trees on the island. But they also created themselves a type of religion that was based on building these idols to their gods. Someone actually cut down the last tree on the island. There was absolutely no doubt that we're cutting down the last tree. They did this. Support this. And there was an entire civilization that was destroyed. This has happened before. We have to remember this. Civilizations have failed in our past. Sumer, which was in southern Iraq, known as the Fertile Crescent, the soils there are completely sunk sand. They can't grow everything because they kept irrigating and irrigating and irrigating, and all the water evaporates and eventually leaves all the salt behind, and you can no longer plant and grow food in that soil. The Roman civilization, there were a lot of other reasons, but part of it was soil depletion all around the Mediterranean as they were growing crops. Same thing with the Mayan civilization in Mesoamerica. And today we're going after the last fish, the last gorilla, the last barrel of oil. Don't forget, in a microcosm of a small island, we still, a human society still managed to cut down the last tree. The trees they needed to build the boats to go fishing. And we have one civilization left. It's primarily a Western European civilization throughout most of the world now, beginning to very interconnected global economy, and we're trying to find that last tree. A few of you have probably heard this one before. When the Voyager spacecraft was sent out, and it got fairly far out, Carl Sagan, when he was still alive, said, "How can we turn it around and take a picture of the Earth?" And I don't want to read this whole quote, but the general idea, if you want to give a sense of who we are in the universe, everything that's ever happened on Earth, every hero, every villain, everything that's ever happened in a pale blue dot, which is on that picture there. So what are we doing to the atmosphere right now? Well, we're pumping in lots of greenhouse gases. Carbon dioxide, of course, nitrous oxide, methane. You can see all of these starting in the 1800s, all of a sudden just very, very rapid increase of how much of those pollutants are in the atmosphere. They're all causing global warming. On the right side is actually the amount of global warming in terms of how many watts per square meter of the Earth's surface of additional heating it's providing to the planet. The odd one out here is actually sulfates. Sulfates actually reflect sunlight. They'll cool the planet off. And there actually are people out there that are thinking if this global warming actually and climate change gets out of control, we can just pump lots of sulfates up there and cool the planet off. The geopolitical wiseness of this, I'm not sure about. I mean, you can imagine. The thing is, doing that is so inexpensive, almost any country can do it on its own. So you can imagine, say, China saying enough is enough, we're going to pump a bunch of sulfates into the air, causes some kind of crazy weather outbreak in the United States and war is declared. So there's some real challenges with trying to do that kind of geoengineering. You've probably seen these type of graphs before. This is the temperature record, primarily from tree rings. We can go back to the 1850s. We can estimate the average temperature for a year from trees, and it's increasing. We can also go back from other sources like ice cores and so on, and we can go back over 1,000 years. And this is the famous hockey stick graph, where all of a sudden, back here, we see this sudden sharp increase in temperature. The global warming that we're feeling now, it takes about 50 years for the carbon that we release from fossil fuels to impact the planet. So The climate change we are feeling right now is due to this, everything that happened basically before 1955. This is all the rest of the greenhouse gases we've emitted since then, and we've yet to feel the impact of that on the climate. So how can climate change affect us? Well, in a number of different ways. I'm just going to focus on one, and I'm actually stealing this from a gentleman named Ronald Wright. And when we look at civilizations, to go back to that idea of civilization, about 10,000 years ago, agriculture, which is the biggest thing that changed humanity, is we learned how to grow crops. We moved from hunter-gatherers to staying in one spot and farming, and we basically domesticated a lot of different plants. And it all happened about 10,000 years ago, yet humanity, in our modern form, and this, as intelligent as we are, had been on the planet for over 50,000 years. So what was so special about 10,000 years that all of a sudden, simultaneously and independently, in many different areas of the world, Peru, Egypt, Mesopotamia, India, China, and Mexico, completely independent places, they all developed their own agriculture. Mexico developed corn. Mesopotamia developed barley, and so on. So it is speculated that what really happened, we were always this smart. Why was it always at this sort of this simultaneous time, independently in all these places? The climate had finally settled down. We were going from hot to warm, ice age, and so on, and all of a sudden things had settled down enough that we could finally figure out how to domesticate some crops. The point being, the food technology of the Stone Age is the one technology that humanity cannot deal without. It feeds us all. And the crops of a dozen ancient people still feed us today, and we have not created, in the last 10,000 years, a single new staple crop. None. The corn, the wheat, the barley, the rice, all that stuff was invented 10,000 years ago, and we haven't invented a new one since. Not even the Green Revolution changed this with fossil fuel-based fertilizers in the 60s, and genetic engineering hasn't changed that today. The crops we have now grow in the climate we have now. I'm also stealing this one literally from, everyone's seen Hans Rosling talk, you can probably find it on TED.com. He did a talk recently, I'm stealing it liberally. And this is talking about economics and population change and how the world is changing economically around it. And he came up with something called the washing machine index. So the idea is, there are, I'll flip on to the next page here. There are about each one of these people represents a billion. So there's 7 billion people in the world. There are 2 billion people in the world living below the poverty line at $2 a day. In the middle here we have 4 billion people, 3 and 1, that have electricity, but only so many of them, about $40 a day, they're above the wash line, can afford a washing machine. And of course, here's us, we're above the airline, we can fly away on our vacation, we have 1,000 gadgets in our homes, we're living on $80 a day, and this is the 1 billion people there. The point of the wash line is, this was an amazing invention. Go back here. She spends 2 days a week washing clothes and linens and has to carry the water all the way down. Either get the water from the river and bring it back or carry everything down. That's a huge amount of time. And imagine the amount of time you could actually free up and do things in your own life, like learn, get an education, improve your life, get yourself over the poverty line, get yourself into the airline. So this is the world as it is today. These squares represent how much energy we use. So 12, don't worry about the units. Energy from fossil fuels, so energy that goes into greenhouse gases. There's 12 of them here. Fully half of them, 6, are used by the richest 1 billion people in the world. The people at the wash line, they've got 2 of them. One's down here and down here. There are 2 things that are going to increase energy consumption. Greater economic output, basically people getting richer, and more people. And generally, you get more people. Most of the birth rates happening down here in the third world, where people are living in poverty. Once you get electrified and move up here, people tend to have smaller families. So that doesn't do a whole lot more to our energy use. This will be by 2050. This is the current projection from UN data. Of course, the people that were here at the wash line, they want to get up here, and they're doing that. That's happening in China, that's happening in India. And of course, once they get there, they're going to start using energy as prolifically as we do. So now we're at 17 units. We're trying to get these people over to the wash, and we want this to happen. We want these people to be productive. We want them to have washing machines. Right? This is good for the world. But look at what it's doing to the energy use. We're up to 20 now. And God willing, hopefully, we'll get these people over the poverty line by 2050. And of course, that will happen. This is the course the world is on. There's absolutely no doubt. The data's been there for the last, you can go to a website called Gap Finder, you can see this happening. It's been happening over the last 50 years, and it's likely going to happen for the next 50 years. This is a serious challenge with their energy use. So what do we have to do? We have to do conservation. And still, most of the energy use is happening here. The richest 2 billion people in the world by 2050. We have to do conservation. We have to do green energy supply. And then once we figure it out, maybe we can start talking to these guys and say, well, now we know how to do it, we can help you out. So this stuff has to happen, otherwise we're going to be almost double the energy use in 50 years from fossil fuels. So, as I mentioned, I have a particular site when it comes to buildings. Buildings consume a huge amount of resources, 65% of total electricity, 40% of the raw materials, and so on. As I like to say, it's the architecture, stupid. We can talk about a lot of other things, but the architecture is a big part of it. This is the McKinsey Quarterly. They put a report out, I think it was about 7 years ago now. It might be dating on this. And they did a sort of a meta-analysis of all the technologies that were out there, from conservation and changing light bulbs to putting carbon sequestration, so taking carbon dioxide being produced by, say, a coal-fired electricity plant and pumping it back into the ground, to nuclear power, to solar power, and so on. And they created this graph. And all the items so each one of these bars represents a particular thing, like building insulation. And all the way up here we have biodiesel. Everything that's below the line means it has a payback. It actually improved the economy. You save more money than you spent doing it. It made things better economically. And everything that's above it is stuff that was just, given the current economics and how we pay things, took money out of the economy, had negative paybacks, in other words. And everything down here, if you look at it, is building insulation, fuel efficiency and commercial lighting systems, air conditioning, water heating, standby. This is all building stuff. Fixing buildings is cash positive. It improves the economy. How are we doing? This is data from the Canadian government, Natural Resources Canada. It's a survey done in 2002. It's been updated, but it didn't change too much. These are all office buildings. These are office buildings built before 1920, built in the 20s and 50s, the 60s, the 70s, the 80s, and 90s. And the height of the bar represents how much energy these buildings use per square meter today. This is not what they used back in 1920 when there wasn't computers in every desk and not many people had lights. This is this old building being used today. And they're all office buildings. This is 100 years of improving building codes, 100 years of better boilers and chillers, 100 years of supposedly getting better, and this is the improvement we've done. So, if you put a straight line on that, and that's a bit of an exaggeration, we're on our way to getting zero energy building by the year 3300. Honestly, this is just data. It doesn't come with an explanation. I've actually shown this slide to probably 1,000 people by now. And I always have to ask them, what do you think is happening here? Does anyone have an explanation? And the favorite one I got from the audience was, maybe it's Darwinian. The really energy pigs back in the 1920s, we bulldozed those because we couldn't afford to keep them. So hopefully the energy pigs from the 80s and 90s, they won't be around in 20 years. When I'm feeling really skeptical, this is why I think the problem is. This is in Ireland. It's just an old Irish hut, pile of rocks. It barely keeps the rain off you. The wind kind of blows through it. But technically, because the rocks are this thick, it's an R2 insulation. This is a Tudor house in Great Britain, R6. They were trying to insulate back then. They wanted to pack insulating-like materials into those holes, so that's what they did. Log cabin, R6 as well, old technology, and again, there's no real insulation in the building. It's just when you have wood this thick in it with R6. Again, R6. This building was built back when our structural engineers weren't that good yet. So we were still building out of stone, and we weren't quite sure how thick the wall had to be to keep the building up, so we made it really thick. And so again, there's no real insulation in the building. There's just lots of material, and there's lots of material between you and the outside. It does provide some insulation value. But we started getting better. Tried to figure out structurally how to make things smaller, and steel came in and made the walls thinner. Then we got R3. This is the General Motors building. They left it a while back, but this is in outside of Michigan. That's outside of Detroit in Michigan. R4. Here's a modern 1970s, sort of pseudo-modern. It really does have insulation in it. But because of all the thermal bridging, due to the basically the shear walls coming out to the outside, from the inside of the building to the outside of the building, and all the balconies also coming from the outside all the way to the outside. It's got about an R12 insulation value, but it's actually achieving R5. But we got better. Curtain wall came. And then we learned how to put low E into the windows, and we got all the way back up to R2. So again, I don't know what this is really going on, and this is part of the issue, but this is what I see being built in downtown Toronto now. Here's one. This building's here in Waterloo. If aliens came down, they would say, I think you have a heat problem. You're trying to get rid of it as fast as possible. This building is designed to get rid of heat. It's got fins on it, cooling fins. This was built in the 70s, and you think we know better. But I went to Chicago back in November, and they got this one, and it won architectural awards. That's a PV panel up top. It generates electricity when the sun shines on it. This is an exterior solar shade. When the sun's out in the summertime, it prevents the sunlight from coming into the building. And to give you an idea of context, this shade saves as much energy in 1 month as that PV panel will generate in 1 year. Which one do you want on your building? My point is, we've forgotten a lot of stuff, yet we know everything we need to know to make low energy buildings. What we need is not as new technology, but when new design practices and more thought of it. Because, I mean, this is just an example. It's just one of a dozen I could show you. This is our new office. It's 22,000 square feet, 3 stories. We got the design for 90 people. It's our new head office. And again, going back to government data, this is the average Canadian office building in Canada. It uses 400 kilowatt hours a square meter a year in electricity. All these blue bars are various LEED buildings that we have worked on, and these are all the bills. This is not the energy model. This is after we collected the bills from these buildings. All doing below that. I mean, we get this one not so great, not as much as we hope, but certainly a lot better. And of course, this is our office down here at 68. Some more numbers on it, but that's not really what I want to concentrate on. What did it cost to build the building? It costs us $180 a square foot, $70 to do the fit up, $250 everything in except the land. That's an extremely competitive price around here. This was not an expensive building. And we're renting it, because we rented, well, someone else, Steve Carpenter bought the building, built the building, he actually rents it back to the company, but we're paying a market rate of just under $20 a square foot. We know how to do this. We absolutely know how to do this. Just because this is facility management, I'm going to try to go through this really quickly. We do have some ongoing operations with the building. We're only purchasing Energy Star equipment. Everything is recycled, of course. Organic coffee, green cleaning. Once a year we do green games. We take a charity and people have games and we raise money. We have committed ourselves to going carbon neutral. And it turns out the building was the easy part, everything else was the hard part for us. And again, it just takes new thinking. And we're trying to get there. When everyone does business travel, they have to put in their expense form, and right there in your expense form, you put what kind of car you got, so we know how much carbon movement when you drove someplace. You can see 90% of it is due to travel after the building. And the largest chunk of that is due to commuting. So we're trying to deal with that. There's the website, so we can actually manage and measure what we're doing. And we're on our way. The biggest difference between 2008 and 2009, of course, is we changed buildings. We went from our old building to that shiny new one you just saw. And we're tackling all the other ones. We've put in a car share for our own company. So we've purchased basically a hybrid vehicle, Toyota Camry. And it's now booked 4 or 6 weeks out in advance now. So it's been extremely popular with our staff. And so the idea is that you have your SUV and you're going to go out to that business meeting. We'll take the hybrid instead. So yeah, we're tracking all this. We're also putting in, we had incentive programs for people to buy their own hybrid vehicles. At one point it was up to $5,000. Between the government incentive program, we got Honda and Toyota in on it, and then our company's incentive was almost $5,000 off a new Honda Prius. And there's this other stuff we're doing for people. Because again, we're trying to measure all the carbon that has to do with the business, and we're trying to reduce all that. So just some real quick conclusions. I didn't talk a lot about water, but big energy and water reduction savings can be made in conventional buildings. We've done it before. It just really takes a different mindset. And that's what it is, new design practices, not new technologies. The widgets have all been invented. I have a whole other slide I should have thrown in here once. I was teaching architects, and it's like, here's a building, it's a perfect box. We throw every widget at it, and I can only get, halfway to my goal of getting the building down to around 50, 60, 70 kilowatt hours a square meter. It's not the widgets, it's the design practices. It's how the widgets go together. Design still matters. Monitoring, paying attention, actually putting numbers behind it. Every time you open up a Sustainable Building magazine or something like that, they talk about these great narratives about what they did in the building. And narratives are great, and narratives inspire people. But we have to get back to the numbers. The greenhouse gases, we can measure those in parts per million. We know what they're doing. We can calculate in numbers what they're doing to increase the temperature of the earth. We need to measure. Every building in this country gets once a month a utility bill that tells them how much energy you use, and no one can tell me how much energy their house uses. But you get that in the mail every month and no one's measuring. We found buildings. For us, buildings was easy. Now we're trying to tackle transportation. So hopefully more on that a year from now as we continue to work it out with the car share. And it takes commitment all the way. This is Steve Carpenter, our president. Dave Suzuki, obviously. But it has to be an entire mindset for an organization. It can't be tacked on. And that's all I got. What should I do?
Open the floor if anyone has any questions or want to ask.
That's never good, actually.
Still in shock.
So by moving into transportation, you mean Enermodal was branching out into that side of industry, or?
Yes and no. But the transportation I meant in this talk was we're dealing with our own transportation with business travel, and of course, and commuting travel, because we're including the commuting travel. Like the whole Toronto office takes a subway now. In terms of transportation, that was one of the reasons. I mean, you may have heard that we're now part of the MMM group. It was one of the reasons for doing that for us. They design public transit. They also design highways and bridges. So we saw that as part of getting into that, and also getting into community design, because that's the other part of the puzzle. You know, we used to design communities so that I worked over here and I lived over there, and I had to go through a 2-hour commute to get there. I mean, that's insane. We have a slide somewhere where there's a whole subdivision, and there's 2 neighbors with their backyards joined together, and you have to drive all the way around the cul-de-sacs over here to drive from one place to the 2 neighbors. So yeah, we do want to tackle that next. That's our plan.
A lot of the energy efficiency when you're going forward running the building, I know you guys are usually involved with the design and the planning of the building. Are you finding that you're getting more involved in suggestions for how to run the building later, as opposed to just walking away when it's done building?
We are. We do 2 things. So yeah, on the design side, we do commissioning. So the idea, just because the plan said so much air goes down that duct, is it really? And of course, it all has to work. But we also do, and that's where some of the measured data you were seeing, measurement verification. And so what we do is we measure end uses in the building, compare them with the computer model. The wonderful thing about the computer model is the operator in the computer model is perfect. Never makes a mistake. And you can calibrate the computer model to how the building is operated, and then start identifying where things are working well and where things are not. And then we send out a report, talk to them, and say, well, there's something going on here, and between that and the commissioning, we can usually find out there's a control not working here or something like that. So we are getting into that, yes. We're trying to get into it more.
Okay, well, once again, thanks. And we'll be taking about a 5-minute break. Refreshments are at the back. You'll be able to walk around, and we'll get ready for the next presentation.